Faults. A fault develops where a rock structure is broken and forcibly displaced. The movement along a fault may be vertical, horizontal, or a combination of both. A normal fault develops from tensional stress, the stress that results when a landscape is rifting or pulling apart. Movement along a normal fault is predominantly vertical, although the orientation of the fault plane may not be perpendicular to the surface. In the animation, click play to begin. As the landscape is extended, notice that one side of the fault plane drops down relative to the other. The fault scarp formed along the uplifted mountain front eventually erodes away, leaving little surface evidence of the fault. Many landforms can develop from normal faulting, including tilted fault block mountains, down-dropped basins known as grabens, and uplifted mountain blocks called horsts. Select Figure 1 to see a diagram illustrating the formation of the Sierra Nevada, a tilted fault block mountain range. Select Figure 2 to see a diagram showing a graben and a horst. A reverse fault develops from compressional stress. Movement along a reverse fault is also predominantly vertical, although in a type of reverse fault known as an overthrust fault, the upthrown block overrides the downthrown block at a very low angle. In the animation, click Reverse Fault and then play to begin. As the landscape is compressed, one side of the fault is pushed up over the other side. Once faulting ends, erosion gradually wears down the uplifted mountain. A strike-slip fault develops from shear stresses, causing one side of the fault to move horizontally past the other. In the animation, click Strike-Slip Fault and then play to begin. Notice that horizontal movement along the strike-slip fault may displace the course of a stream. Such offset streams commonly develop from ongoing displacement along a strike-slip fault. Select Figure 3 to see a diagram illustrating common landforms that develop from strike-slip faulting. Select Figure 4 to see a photograph showing displacement along a strike-slip fault.
After reviewing